yeah, so there must be certain rules that you must be abide by, that and those rules can be anything based on your organizational or process or product, whatever you're working on. And mostly if you're working in infrastructure as code ecosystem, then most of the rules or most of the things that will be defined by your team, as you do in any kind of practice that you do within your infrastructure as infrastructure teams. Then the second thing, as the name also has the version control also gives you the flexibility to manage your versions of your infrastructure. So versions of application is pretty much common. People, everybody knows it, that you have application version 1, version 2, version 3. But for infrastructure, it is a little bit of a new concept, if I would say. If you have an infrastructure, if you have a server deployed in your production, and then you make some changes into the production, then if you are doing it via infrastructure as code, then definitely you must have some way of managing these versions, so that you can roll it back, so that you can remember what was earlier, what is next, and what can be the future, and those kind of things. Whatever, versioning is one of the common practice when you are doing something related to code. And then version control is the one way of having that versioning system in place for your infrastructure as code. So this makes sense. If you are working on some Terraform or some ARM template, and if you have orchestrated your infrastructure, but everybody knows that it will never be the same thing over a period of time. There will be some changes, some port additions, some disk size changes, some machine type changes, and all those things will happen. And those things are only you will be able to use when you are having history. And see, I have kind of particular animation from the internet, but what I am trying to show here is that if you are doing some changes into your infrastructure, you must be aware of people in your are making into the the code, what change, when it happened, whatever the changes that is happening over period of time in the code, if it is deployed, if it is not deployed, all those things. This kind of history is another very important aspect of version control that you get, and that is really important for infrastructure engineers. So you have defined your infrastructure using ARM template or any other script, PowerShell or anything. Then within your team, someone changed that script and deployed it into the production. Now the production is working in a way that it is not supposed to, or maybe it is working as expected, but still you need some kind of traceability, that what was earlier, what is now. If you don't have a version control in place to track your code changes, then it will be very difficult to track down who did what and what made those changes appear in the production or in the test or in the dev and all those things. So these are the main three main things that you get with any kind of version control. And then we will go and we will try to talk about Git in the next slide. But yes, version control is pretty much not specific to Git only. There are n number of, there are a couple of version control, not n number of, but there are a couple of version control system available in the marketplace, and each one have their own specification and own advantage and disadvantages. We will talk about little bit of advantage of Git in some time. But yeah, version control is one concept, and then Git is one of the implementation that you get, and that's what our next slide is. So what is Git? So Git is known as, if you search on the internet, you will get the definition. It is a distributed version control system. So it is a type of version control system which is distributed in nature. Now, what do we mean by distributed in nature is this. So you have a central main repo server, and if you are coming from infrastructure background, who have not worked with the Git and all, then you must have heard of something like GitHub. right? So GitHub is one kind of central main repo server. GitHub is something which is SaaS product, which is publicly available, but you can have your own main repo server on premises as well. You can download Git, which is open source software, install it on your own server, and make it kind of a version control system that GitHub provides. So GitHub is something they are providing you this central main server freely now with certain kind of limitation, and then they have an enterprise offering as well. But it is nothing more than a server client architecture, I would say, and there is a server which is residing somewhere in the remote location, and that is what the central main repo server, what we call in terms of Git. And when we say that this is a distributed repo server, then this is what we mean, that you have one central repo server. You can have copy of that particular repo, I mean the file, in your local machine by pulling it from the central repo. So the first time you do is clone. We will talk about all those things during demo as well. The first time is clone, and then and then onward it will be pull. Pull is like you are pulling it on local user one machine, and then somewhere other around there can be another user on another machine who will be pulling the same type of code on his local machine, and it is nothing more than copy of the exact same central main repo server. It is like you have a copy of file on the repo server. You are just making replica on multiple machines. It can be n number of machines. Distributed architecture it is now, and then user 1 and user 2 can work independently together parallelly, and then they can they have their own set of files. When they copied the files, they have the exact same replica, but then they did some changes into the files, and then they had a different kind of files on the local system. So user 1 has made changes which made red. Red is like just reflecting a different kind of change, and then the other side is green or pale green. That is another, it is just reflecting a kind of a change that is being done by a user. And that's what we do in distributed teams actually. So you have a user A who is working on certain aspect of the code, and then you have a user B who is working on certain aspect of the code. And that's how this works in application development, as well as that is how it's supposed to work in infrastructure as code ecosystem as well. Then once you have all these changes, each user commit on the local repository their changes. We will look into it on the during the demo, but this is what happens when you do certain changes. Then you're supposed to commit those changes on your local machine. Once you do those changes on the local machine, then to make it available on the central main repo server, you have to push it. So user 2 is also pushing it, user 1 is also pushing it. They should not push. There is some kind of discipline that has to be there when people are pushing their changes onto the central main server, and that we will be talking about in next slides. But that's how this is what a life cycle of changes regarding the repository happens in terms of Git. So that's why we call it distributed version control system, because you have the same copy of code on multiple places. Multiple people are working together, and they are making their changes onto the main server. And once they have made those changes, each one can fetch it by using pull, and they update their each code by the with the other changes that has been pushed into the central main server. So what do we mean by that? That is that user 1 has pushed some changes related to user 1, and user 2 pushed some changes related to user 2, and then when they pull it, both of them will have their opposite changes. So user 2 will have now user 1 change, and user 1 will have user 2 change as well. Yeah, I mean their respective change was already there on their local server. So that's how the life cycle of the Git or I mean version control or the code life cycle works in a Git version control system. And we will be seeing the complete demo in a bit. But this is essentially the very basic thing that happens in your version control. There are certain disciplines that has to happen to make sure that certain changes from local user 2 is not conflicting with the certain changes with the user 1, and all those kind of governance things are there. We will be talking about those things, but this is overall workflow, I would say, or flow of the changes that happens on the Git server over period of time within a team. That's what it is. Then we have a Azure Repo. We will be kind of demoing the Git using this. This is one of the version control, what I would say, a managed Git by Azure DevOps application by Microsoft. So Azure Repo is something you can relate with GitHub, Bitbucket, if you have heard of these names. So it is nothing more than a Git centralized Git server provided to you with certain limitation as a free account, and then if you have an enterprise account in terms of GitHub, they will add some more benefits, like you can have on-premises server and all. In terms of Azure Repo, they have an Azure DevOps server for on-premises solution, but it is a kind of a software that you have that you can use to do or to start with your virtual system thing. Now, before we start, or before we, if you are very new to the version control system, then what are the things you must have on your local machine, or you must have to have in terms of account and all? These are the few things that you should be aware that before starting. These are the things should be, you should be downloading, or you should be creating account with those respective things. So the very basic thing is Git. So Git is a free software, open source software that you can download from this URL. You can do a Google and you will get the direct download link. You must have this Git on your local machine, because as I have shown you that in the distributed version control, you have a local version control as well, local repository as well. So to work with the local repository, you must have a Git downloaded and installed on your local computer. The next thing you will need is one of the code editor, because essentially you are managing your code. So VS Code is one of the very popular code editor right now. Either you talk about Microsoft ecosystem, or you talk about any other platform development ecosystem. VS Code is getting really popular these days, so must have this particular tool. And if you are an infrastructure engineer and you don't want to get into the complexity of Git, then VS Code is the a lifesaver for you, because this is what we are going to show you, that using VS Code, having minimal knowledge of Git, or having minimal or going through minimal things of Git, you can do your version control across your team very easily. So VS Code is the next thing. And then of course your code that you need, because that's what you are going to manage using Git. And then your Azure DevOps or GitHub account. So we are going to demonstrate using Azure DevOps. So you must, if you are going to replicate the similar kind of experience, then go ahead, use Azure DevOps. But GitHub is also okay, or any other version control system is fine, because the demo is not essentially about Azure DevOps or GitHub. It is about how to work with any Git distribution, whether it is GitHub, whether it is Bitbucket, whether it is Azure DevOps, or any other available on the marketplace. Now, when we talk about Git, there are on the maturity of learning, or I would say based on how many things you should know initially when you are just getting started with the Git. I have made two types of users. One is get started, which is self-starter kind of a user who is more or less their team do not use Git yet, or might be they have a a plan to use it, but right now the team is not really ready to adopt this particular thing in their ecosystem. So those kind of user can use at least get started kind of pointer, which can help them work with a Git, not in the very best way, not in a very best practices or pattern way, but essentially it is a very good way of starting with Git and then knowing the ecosystem and getting into this ecosystem slowly. And so what are the main pointer that you must have when you are in the get started mode or self starter mode, where all the kind of team complexity and all those policy and all those things are not really a thing to consider. Then what are the things you must be aware of? So first of all, you must create a repository. You can create a repository locally, but I will recommend you to create a repository on some public Git offering like GitHub or Azure Repo. And then you should, once you have created a repository, clone that repository on your local machine. When you clone it, you have a copy of files here. Then of course you make changes into the files, and then you just commit the changes and then push it to the main repo that is on the Azure Repo or GitHub. This is a very simplified version of your getting started or self-starter mode. It's if I would say most of the people will start with this kind of pointers if they don't have a team who really work on Git in a very matured way. But this is something, if you are kind of a very starter, there is nothing that you can do mistake about it. There is only one guy who is making their changes. It's just that you are not making changes on the local computer only. You are whenever you are making some changes, you are keep on committing those changes and pushing it back to the main server so that you have a copy on the main server. And during this journey, you are kind of making sure that you are getting familiar with the ecosystem, getting familiar with the commands, getting familiar with the flow of the changes that happens with the Git Git tool. So that is how you can start with this particular thing. And then the next is little bit better with the team. So this is the ideal. I mean, I would not say ideal, but this is the thing which will work in a team that which is pretty much a very practical team who is working on infrastructure as code, and they are kind of they supposed to adopt the version control into their infrastructure as code tool ecosystem so that they can get the benefits of whatever version control system gives. So the first thing you get is you create a repo. Sorry. When you create a repo, you get a master branch. And that master branch is applicable when you create a repo, I mean, with the self-starter as well. But when you create a repo and when you're working with team, you don't make changes directly into the master. What you do is you discuss the branching strategy. Branching strategy is something that is kind of a very important aspect when you are working with a Git version control system. So there is a famous branching strategy known as Git flow. I would recommend you to Google it. There are multiple articles available on internet what exactly the Git flow is. I have made a, I would say, simplified version of Git flow, which is the simplest one that a team can start with. So, and that is very, very important when your team is just starting with Git journey. So when your team is starting with Git journey, you don't want the unnecessary complexity into your system. So that's why, Git, when you start discussing your branching strategy, having Git flow, branching strategy in the background, you try to make it simplest if you are trying to govern your branching strategy. And why you need it, we will talk about it, but you definitely need it. And why you need it, let's go to the next point and I will show you. So this is one of the very basic or very simple branching strategy I have derived, and which is inspired from Git flow branching strategy. You have a master branch, you have a dev branch, and then from dev branch, you start creating feature branches where respective developers or respective infrastructure engineers will work. So feature A can be creating a ARM template for virtual machine. Feature B can be adding extensions or DSC extensions or custom script extensions to a virtual machine template, or it can be another virtual machine template for SQL or something else. But essentially, feature A, feature B are temporary kind of branches that comes out from the dev. So dev comes from the master, then feature comes from the dev, and then everyone works on their each branches. Once they are they have done the code changes, which is which as per them is okay to replicate over to the remote server. Instead of making directly to the master, they will first, feature A will make changes, merge it back to the dev. Feature B will merge back to the dev, and they will do it using a pull request mechanism. So in Git, you have a pull request mechanism. Using pull request, what you can do is when you do certain changes, you can kind of create a pull request to merge it back to the parent branch, that is dev branch, and then so a reviewer can be assigned there who can do code review. So whatever feature A is supposed to do will be reviewed by certain people, maybe supervisor, maybe some senior person, or maybe just another peer in your team who is doing your peer coding and something like that. And then once you do those changes, and once dev has all those changes, then the final pull request will be created to merge it back to the master, and then that will be the actual code which is supposed to be released. And when you release a code, you tag it. So you tag 1.0, 1.2, 1.3, whatever it is. And then once you tag a version, then before starting the next cycle, you merge it back to the dev, and then the next cycle continue. Like feature C will be carved out from the taken out from the dev, and then again they will work together, and then they will merge it back using the pull request, and then all those things. We will see all these things, how basically they happen in a very simple and practical way. But this is the life cycle that I'm trying to demonstrate. When you do Git, or when you do version control using Git in your team, these are the things you should make sure. You definitely has to have a branching strategy. You definitely have to have those changes merged back into the parent branch using some kind of pull request with the reviewer in place in the whole cycle. And then there are a few things that has to be remembered pretty much basically from the previous slide only, that always have a branching strategy. Simplest is better. Yes, you should always discuss your branching strategy when you're working within a team, and when you are using a Git version control, you definitely go ahead, search Git flow, read about it, and see see how this thing applicable to you. Kind of customize it as per you, as per your team, as per your product, as per your infrastructure, and then make it the simplest one which should work for your team. And then at the same time you are following some best practices in place. And then if you have some question around Git flow, feel free to post it on in our group, and then we will be trying to explain those things which might be whatever the confusion may be. But this is a must thing you should have. You start discussing within your team this is the Git flow which kind of propose, and how you are going to adopt it for your team by making certain changes which are not applicable for your team, or maybe applicable for your team in a much better way. Then you must remember that do not direct push to master or dev branch as per our previous slide. So we have to master and dev. You should not do any changes which is a collaboratory branch, I would say. So master is the main branch, which is a release branch, which is in the production running fine, everything is there. Dev is the development branch where ongoing development is happening, but this is the branch which is point of reference for all the developers for the current development code. So no direct merge, no direct code push should happen on the dev branch if you are working in a team. So then have branch policy to secure the merge. Then there is something called branch policy in Azure Repo or GitHub and any other Git management software, where you have a kind of a policies where you can define who are the people can approve the pull request, who are the people can create the branch, who are the people can delete the branch. So those kind of security controls you should have in when you are working as a team in your in infrastructure as code. This does not apply for self-starter pointers. As I said, self-starter is more of like your learning process. That is what the getting started kind of thing. But this is more of like adoption kind of thing. Once you are familiar with the ecosystem, once you are familiar with the tool set, editors, and all those things, then all these things apply to you. And then after mature version control, so once you have the version control process maturity in place, make sure that you start looking into the CI, that is continuous integration part of the DevOps practice. So having a version control itself is one of the major requirement for continuous integration, and continuous integration is one of the main advantage you have when you are using a version control. So it is kind of a vice versa thing, that once you have a version control in place, you can make use of CI practice, continuous integration practice. And if you want to achieve your continuous integration practice, you have to have a version control adoption in place to start with. So this is one of the thing to point to remember, I would say. And then on the next slide, we have some useful links that you can refer. One of the third link is about a very good graphical article about Git flow branching model. Must have GitHub link, and then you have this Azure DevOps, Azure Repo product link. This is what I will be posting this slide in the group, or will be sending the email with the slide as well. So you can refer these links during the presentation, as well as on the last slide, and then you can start your journey. So let's have a demo. This is the demo part now. So let's start the demo, and then let's see how it works, and then if at all some questions comes in, we will try to cover those questions during our demo or after our demo. So let me share my screen. So okay. Okay. So I have this Azure DevOps opened. This is my account. I'm going to create a new project over to demonstrate today's demo. So I will say Git session project. When you create a project, you get to option in advanced. By default, it will be selected as Git, but there is another version control system, which is Team Foundation version control. You can opt, but Git is the most popular version control, and you should, if at all you have decided to use Git, then you should only use Git only. Is the work item. Whenever we will have session around this work item process and all those things, we will try to cover this. But this is the very basic thing. I will make it public, right? So that you guys can see all those things. Once you create a project, you have the option to get. You get a few of the services as part of the project. We will see all those services. Right now, our main objective will be on one of the service that is Azure Repo. Let's see. So you can see that there are services like Azure Board, Azure Repo, pipelines, test plan, and artifacts. But my current, our demo will use this particular service. So if I go to this service, and if I go to, so by default, it creates one repo. You can create multiple repos in a project, but for the time being, we will use the default one. So this is the repo that you have. Now, there are multiple ways to get started with, and you can see that there are multiple ways you can initialize this repo, you can import a repository, you can do any number of things here. But we will just, what we do is we will pick first option and we will use this step to kind of do our further demo. So I have copied the clone URL. I have copied it. Now I will open the folder on my repo. So this is a folder that where I keep my repositories. So what I will do, I will open Git bash over here. So when I open Git bash over here, this opens like this. There are multiple ways of again doing this, but I am just making sure that it should be very simple to follow. At the same time, you can kind of use it. I mean, you can make it as complex as it can be, but I'm trying to be very basic for introductory demo. So I will say git clone the URL, and then that's it. So there are multiple ways of, again, there is another way of cloning as well, which uses SSH. We are not using SSH way of cloning. So the moment I have cloned, if I will refresh my folder, I should have a git session folder here. Let's see. Check cloning git session. Oh, okay. Unable to open SSL connection to Visual 443. Okay. It looks like my Git is complaining about it, but let me try another way. Yeah, refactoring one you appear to clone and yeah. So because I have some changes in my Git setting, which is not letting me to clone the HTTPS URL, but now it has cloned. If you can see, I have Git session folder over here, which is my repository, but it is empty, and that is what the warning was. You appear to have cloned an empty repository. Now and you can see that on the server side, if I go there, if I'll still refresh, it will give me the same kind of interface because there is no file yet. Now what I will do, because I'm using Visual Studio Code, once I have the clone of the repository, I can clone it using Visual Studio Code as well, but I have used Git to make it very native experience, and then now to update any code changes, I will use Git Visual Studio. So I have opened Visual Studio Code in this folder. Let me drag it over here. Right. So, okay. Now there is no file over here, right? So what I will do, I will create a README file over here. .md, right? Yeah, simply just it's initializing the extension. Just a simple change. So what I have done is I have created a file over here. The moment I have created this file, Visual Studio Code automatically picks those changes and shows me that these are the files that I have created, and this is the change that has happened with this file. So if I want to commit, or whatever I want to do, so what I will do, I will commit. I have committed it. Okay, so it is. Oh, it is something else. But yeah, it has committed. The moment I have committed it, I have this thing to publish those changes. So if you make some changes on the local computer, and if it is not applicable on the on the server, then it first time you have to publish it. Now before we publish, let's go ahead and refresh this browser again. There is no change yet because I have not made any changes here. Publish it. Okay, it is asking for my credential. So I'll say okay, authentication failed. So must be some changes to my Git because of which my authentication. Let me authenticate again. Somehow using my corporate account on this laptop, and that's why it is not able to authenticate. Let me think. It is working. Something wrong with the Visual Studio Code. It looks like some update or something. Okay.
Hello, Ashish. I think you have to
Yeah,
change to on Git credentials in Git repo.
but this is actually and that's what, like when you do it with, because my Git is actually configured with my this DevOps account. It is
Okay.
like, yeah, I
Uh,
mean it's just that because of some reason, some changes into the Git configuration, it is like it is not accepting my, it is actually picking up the credential for my corporate account that is
okay.
got,
Okay.
yeah, so because of that only, I mean if I will do it for some other, I mean so like personal access token and all those things will be needed if I have not configured my Git. But this is strange, it was working in the evening itself. uh, let me try one more time. Let me try to update my Git credential. Okay, okay. try one more time. To move this. Definitely some issues in connection to dev. Unable to access. It is not accepting SSL connection as well. So it doesn't look like it will work. Let's try. Oops. This is what you're talking about. I am trying to do this second option.
Okay.
Copy this code and present. Copy this code and present. Oops. Oh, then again this. Now it should work. Yeah. Requesting personal access. It's not giving access token. Let's try this. It's not able to get the access token. Let me try this. Somehow the automatic access token is not working. Nope, this is not working. I was not expecting this. This is the worst thing. Let me try other thing.
One thing you can check whether your system is in a proxy, under proxy or not. If it is,
No,
are you?
Yeah, I am working from home, so the proxy and even it was working evening. So let me do one thing, the same thing here in GitHub. So I will say git demo, and it will be public. Let's do not initialize it. Create repo. So let's clone it, and let's close this one. Yeah, I mean some changes to related to my Azure DevOps organization, which is not working for this one. So let me spin this with git bash here. Yeah. So we have this git demo. We will do the similar kind of change here using Visual Studio Code. I was not expecting this, but it happens in demo. So what I will do, I'll create a README file. Simple file. We should not do any changes directly into the master branch, but this is the getting started or the self started kind of thing. So that's why it is okay to do this if you are working individually. Simply this. Oops. And save it. And let's see, the changes are here. Let's commit. And the moment I have made some changes, I'm publishing those changes. Hopefully it should authenticate with my GitHub. So it is asking, okay, looks like it did. Now let's refresh my GitHub repository. So we have this file over here. This is okay for a single kind of, single individual contributor kind of thing. But this is not okay for any kind of team contribution or team work, right? You should have a branching strategy. You should have a pull request mechanism to make sure that not everyone can, merge the changes into the master branch. And that's where all these things, security and all those things comes into the picture. Every kind of Git management software will have some way of managing this service, managing this security policy. Just like here, if I will go into this and let's go back to my organization. If you go to the repository, here there is no file, so I don't think it will show me all the settings. But let me see. While it is updating, let's see, go back here. So this is the way. I mean, like, you have those changes. Now again, you do some changes, like, do something like this. Introduction, make it a little bit better. Introduction to Git, right? And my second line of update, right? And if I will do those changes, it will see all these changes. So this is the benefit you get from the definitely some issue with my Visual Studio Code that happened, because of which multiple extensions are failing. But here what I see is introduction to Git. My second, so second is this. Yeah. Second line of update and all those changes. I want to make those changes. I will say second line changes or whatever meaningful commit messages, so that anyone can detect what changes might be as a part of this commit. The moment I make changes, and since the file is already there on the server, you, instead of publish, you see the sync icon here in the Visual Studio Code, that one change up, that is one change is going up and 0 changes coming down, that there is no other change other than you that you are sending that is coming down. So this is what it means. How many things are going up, like you are pushing, and how many things you are pulling, if at all someone had made those changes. So since we are the only, I mean, right now on this repository, I am the only one who is working and directly working on the master. So yeah, 0 changes to pull. And the moment I will push all these changes, it will be available on the server. Again, this is what we are doing here, is single person changes, right? It is not, this is not how team does work. So what we do is, you should do is, either you go here and create a branch from here, from the Visual Studio Code, you can do that, or go to your managed Git server. I mean, whether it is GitHub or whether it is Azure Repo, GitHub server, Bitbucket, or whatever, discuss among your team what branching strategy you want to follow, and have a consensus about that and then create those changes. So as I have shown the the diagram, I will make the branches according to it. So I'll create a dev branch based on master, right? So master is the main branch that I have. Dev is the development branch that I have. But again, dev is not something which is supposed to be changed directly. So what I will do, suppose I am someone who is working on, suppose, a change that is like feature, and the branch name is feature followed by something like whatever I'm working, VM template. So I'm working on something related to VM ARM template. I'm creating it from dev, right? So dev does not have anything. And right now, when I created all these three branches, right now all these three have, I mean, same code. Master is the default branch, dev is the development branch, feature is the feature on which I am working. Someone else will work on some other feature, they will create their own branch. And then what I will do, I will go here in Visual Studio Code. It will take some time to kind of synchronize those features which are available on the repository. So what I will do, I will keep on syncing a little bit. This is one of the problem in Visual Studio Code, which does not kind of take those branches which is created on the server side instantly. So you have to keep on refreshing and then you get all these branches. So right now, suppose I supposed to work on this feature branch. So I'll take this feature branch, right? The code is same, right? Code is not changed because I have not done any changes yet. So what I will do, I will go ahead and make some changes specific to my code, that is my VM code. Right now, to demonstrate, I'm not creating really a template over here, but what I will do, I will make some changes. This will create a VM and I will save this and I will go to files and I will create another file as a part of this branch and I will say deploy.ps1 and I will say this is a ps file for template deployment. I mean, I'm just saying it, making changes to just to reflect you how it works. So I'm making it as a comment line, deployment, right? Deployment spelling, right? And then I will create a dummy ARM template, maybe like ARM VM.json, right? And the moment I will say this as JSON, dot JSON, rename dot JSON, right? I will say something like this, skeleton, right? Skeleton, just like a sample skeleton. So these are the changes I have done based on my feature request. But this is in this branch, right? So what I will do, I will simply go ahead and check. Okay, these are the changes I supposed to do. I have done all these changes. Merge VM ups VM. Yeah, hello. I think the internet was disconnected for a while. Okay, so what I will do, I have those changes done, and now all I have to do is I have to commit all these changes on the server side in the same branch, in the feature branch only. So I have done VM code fixes, and then there is another pattern. What I was showing is if you say hash pound sign, and then if you mention issue number or work item, then it will automatically attach it to the work item. So I mean, this is one of the a way to do this, but then right now we are not demonstrating this particular thing. So VM code, I will just say VM code and save all and commit. Some few files were not saved, so I am committing all these files, right? So one change is going there, so I am committing these changes and let it push there. Okay. And let's go back and see the changes here, right? So we are in the feature branch. We can see that JSON file is there, deployed it there. Nothing as such, functionally, nothing is there. But we are, I mean, we have those changes. But if the moment we switch the branch to dev or to the master, you can see that those files, I mean, those files are not reflecting here. So whatever the developer Ashish has done is still in his branch and is not affecting anything which is already there in the production or with the other team members. To make it available to the team, that's where the branching strategy comes into the picture. So in our case of discussion, we decided that our branching strategy will be feature to dev and then dev to master. So what I will do is, as you can see, GitHub is automatically picking it up, that it says that you have certain changes in this branch. Do you want to compare and pull request? So create a pull request. Yes, I want to compare and create a pull request. So the moment I will say compare and pull request, it will say against which branch you want to compare, whether it is master, dev, or the branch itself. So if I will say the branch itself, it doesn't have anything, right? But the moment I say I want to compare it against dev, it will show me, things that the things that have changed. 3 files have changed, right? What are the changes that happened? And it shows you that, in read my, I just added another line, but in arm.json, it is completely new file. And in this new file, this is the content. And then in the deploy ps1 file, this is an entirely new file. And then again, there is a content here. So this is the way you kind of give this all these things, and then you can add reviewers over here. I mean, right now the settings I have not created to add reviewer and all, but you can add reviewer here, and this particular option is available in Azure Repo as well. The moment you add reviewer, and they're supposed to review exactly the same differences here. They will see if developer Ashish has done the changes which is applicable to this feature or not and all. And then I will create a feature request. I mean, I will create a pull request against this dev branch, not against master branch, because master is our main branch, release branch, I would say. So dev is the ongoing development effort from where all the developers will be referencing their changes. So dev is there, but I will make changes to the dev. So I will create a pull request against it. Because I am the administrator for this repository, I have the option to kind of merge this pull request or approve and merge this request. But in case of in a team way, you should have the branching policy and securities in place so that whosoever is able to merge this request should not, I mean, the same person should not be able to merge the request. First of all, if Ashish has created a pull request, Ashish should not be able to approve this request and merge it. Either someone else has to approve it and then Ashish may be able to merge it, or maybe someone else will approve and merge it back. So these kind of security that you should have in place when you are talking about Git version control in a team. But this is the workflow that I am demonstrating, that you create a feature branch, you did some changes, you created a pull request against a development branch, you merge these requests, confirm merge. The moment I confirm merge, it will be available in my dev branch. Now let's go back to our branch. If I will see this feature branch, it still have all these things. If I go here and see dev branch, I have all these new things here. But the moment dev is there, it again says that, okay, this has some information which, and this dev branch has a parent. Do you want to compare and create a pull request? Of course, this should not happen frequently. This should happen on the release level. Dev is something where all the developer will kind of concentrate on working, and then suppose Ashish code makes sense to someone else, then someone else will pick the code from the dev branch, and then they will merge it back, and then they start working. And the moment they will decide that, okay, dev has all the bits and pieces together by Ashish, by someone else and all, then the final pull request will be created against master from the dev, not from the feature branch. And then, all these things will be the same cycle. But this is how you make use of, pull request mechanism in a Git version control system. And in Git version control system, pull request together with the branching policy and branching strategy makes your team more governed, and it makes your team more efficient in terms of coding and all. So, and why this makes sense for infrastructure engineer, the most important part is that when you start working with the adoption of infrastructure as code, then you no longer work in a very different way than developers do, because you are also working on the coding level. All the matrices that applies with the code, like technical depth, continuous integration, continuous deployment, all those things will be applied to you as a team as well. And when you are talking about all those things, then the governance model will also be the same. So that's how these things work together. I tried to make it very, it was easy for me to do it in Azure Repo, but somehow my Git messed up, and then my Git is not working with my Azure DevOps. But yeah, the similar thing, it works with any kind of version control. We have demonstrated with the Azure, GitHub. You can do it, the similar thing with Azure Repo, similar thing with, Bitbucket or any other thing. Git is Git, irrespective of who is the vendor. But the basic concept about branching strategy, basic concept about, pull request remains same, and the branch policies remain same there. This is what we have today, and I think we are already above 17 minutes. And then, yeah, somehow I will try to create a demo for Azure Repo and upload it on YouTube, because we are not able to demonstrate it today. I will fix my Git for my personal Azure DevOps service, and we'll see. We will upload it, and we'll share the link in the group. But I hope this, the demo that I have done with GitHub is making sense to you. And if you have any question, you can definitely go ahead and ask. You can unmute yourself and you can ask any question you have. No question. Am I audible or? Hello.
Yeah, you are audible.
Okay, thanks. Yeah, so if you don't have any question, that's fine. We messed up with the demo. I see that, but yeah, I will upload the demo on YouTube, and hopefully what I'm thinking now is we will be trying to continue the session on ARM template, make it a little bit more advanced, and I hope this basics of Git will yeah, okay, so yeah, we will soon post the next webinar details in the group, and I will share the recordings and slides, as well as Azure Repo demo for the similar kind of workflow that I have demonstrated with GitHub, and hopefully it will make sense to you. And nothing else from my side. If you guys have any question, you can ask. You can post it in group as well. And yeah, that's it.
Thank you, Ashish, for your session.
Thank you.
Can you share the YouTube link?
group?
Yeah, YouTube I will share in the group itself. Yeah.
Okay.
You need group link?
Yeah, group link. What's the name of that? Actually, I'm the new. I got the link from my brother, so I don't know about your group and YouTube.
Oh, okay. Let me give the. So this is the group link that I have sent in the chat. This is Telegram group that we have, and I have a YouTube channel as well. Let me share the YouTube channel link. Okay. So I'll be posting the slides as well as the recordings in the group, and we'll be posting on the YouTube of course, and we will make sure that you will have the Azure Repo demo as well, which we were not able to demonstrate during the session. Okay, yeah, thank you everyone. Thanks for joining, and have a happy new year for next year, and hopefully this year went well for you, and hopefully you will get the good nice learnings in the next year as well. Thank you. Thanks.
Thank you. Same to you.